Hello and welcome to my NeuroCave++ demo. My name's Morris Chuckman and I've been working on enhancing the NeuroCave web application, adding some features that will be pretty useful for neurogenomics and general omics graph visualization. So as you can see down here, we have real enter VR buttons. I can't use those because I'm running Linux right now, but no more keyboard. And I also have these sliders. It used to be just one slider to control the glyph sizes. Now I have two each for each window, so you can unlock them and control the spheres and cubes separately for the left and right viewing windows. And it really gives you some fine-grained control, so you can import multiple data sets combined. And so I remap the spheres and cubes for the neurogenomics data set. So here the cubes are the right hemisphere, the spheres are the left. So you can control them independently here, and you can also control the. I have a separate set of sliders for ipsilateral and contralateral connection weight thresholds. So if I turn a bunch of edges on here, I can control the threshold for the contralateral edges and thin them out a little, and I can maybe enhance the ipsilateral connection weights, or I can use these checkboxes, turn them on and off entirely. And I can also remove the contralateral ipsilateral weights from the top 10 edge view rather than the weight threshold based edge manipulation. I can also unlock the region coloring panel, so I can turn on and off different lobes in the anatomical view, and I can actually select a whole new color scheme for the other pane window view window, and I can pair that with the isomap dimensionality reduction and the complementary view coloring, so I can compare them, the two different visualizations side to side right there with their own customized coloring. And also there's a search box, so I can search for, say, maybe the singulate, so if there's a phrase in my mouse just died. I wonder if it's the battery. Yep, appears to be the battery. I'll probably edit this part out later. Okay, we don't have that one. Maybe lowercase. Oh. Maybe that's not in the... Oh, it's right there. Sing. Oh, I have a couple spaces in there. So there it is. So I imported this Neurogenomics data set that I downloaded from the Allen Brain Institute. And they have MRI data that's paired with microarray data. So they have these 500 samples per hemisphere, so that's about 1,000 samples per brain, and they have their 3D anatomical positions recorded. They microarrayed them with 62,000 probe microarrays. So I can look, and they have a simple website here. I can look for, say, maybe a transporter, a monoamine transporter, and you can see that there's a simple little heat map there. It looks like it's gene symbols SLC18. So maybe let's see what all the SLCs are. There's all the SLCs, or a lot of them. So you can get a nice heat map there, and see at the top they have the region that it's expressed in. They have some, red and green patches over there. But I imported this into NeuroCave and processed it, so it's going to be a bit probably edit this part out too. It's probably going to be a bit better to view in 3D as a graph than as a heat map. So this is the Allen Brain Institute imported data set for one of the 4 donors that had DTI, MRI, and T1 weighting. So that allowed me to calculate its connectome. And these are they had about 950 or so sample regions that they sampled tissue from and ran it through a microarray. So I can highlight these, and they have a nice mouse over flashing effect. And so this area over here is the UMAP dimensionality reduction embedding of all of the genes in the data set. And these edges represent the genes expressed in that region that was sampled. So I use these sliders to manipulate the edge weight threshold. So now I have intragroup and intergroup thresholds. So this would be an intergroup because I represent the cells or the regions, the brain regions as spheres, and the cubes now represent the genes. So I can now use the two view windows to display close-ups of the two groups. The brain regions group can be on the left, and I'll put the UMAP brain brain genes embedding on the right over here. So I can thin out the intergroup threshold. So now we can see which very clearly which genes and which connectivity modules of the genes are expressed in that brain region. The edges are color coded to reflect the starting and end points. So and of course, if I'm not interested in that, I can set that pretty high, and then I can lower the threshold for the intra-group edges. And now I see the various edges, the connections, the connectome connections between that region. Which is the middle frontal gyrus. Or the inferior frontal gyrus are pretty close together. Looks like that only has one connection. So I can view the top 5 or 10 or more edges there, and I can adjust these check boxes to exclude the connection types that I'm not interested in. I can increase the number of edges. Yeah, that one's now very highly connected, I guess. So now this data set has the genes and the brain regions all in one data set with one connection matrix and one atlas that has both genes and cells on it. And so the two views have the genes and cell and and the brain regions in different hemispheres, sort of in different groups. So I've generalized the concept of the hemisphere to represent genes and cells. So, but the two, they'd have different placements in terms of the foreground and background. So if I'm interested in the genes in all the brain regions that express, like, say, the SLC genes, then I can search for them and I can select, I can get them selected. I have some animations here, so sometimes it's hard to see which genes or cells were selected in the search, so I have them flashing there. You can turn the inter group back on, and now I can see which brain regions have the most SLC genes expressed in them. Turn the middle front gyrus off so that I don't need to have too many edges that going the wrong way. So I can turn the edge opacity down, and with these animations you can now see through the edges, but you can still see which of these nodes are either selected or connected to the selected cells. So you can now explore the connectome of the SLC expressing brain regions. You can also control the the color scheme here, so I can keep the anatomy based view on the left, and on the right, say I'm interested in long non-coding RNAs that interact with SLC genes. That's the solute carrier genes, including monoamine oxidases, carrier transporters. So I can change the color coding. Except it didn't change. Turn the skybox off. Okay, now it changed. So if I'm not interested in protein coding genes so much, I can make them kind of dim, and I can get a much better look at the long non-coding RNA. Make the coding genes go away entirely and see just the long non-coding RNA. So I know that my SLC genes are highlighted. Like maybe click on some of the long non-coding RNAs. I can see which brain regions are expressing them. The UMAP presentation really shows you, how the different modules interact with one another. But if you're just interested in the modularity and you want to have that brought out, you can use this platonic solids embedding representation. I can use the appropriate color coding there. Well, that's all I got for now. Thanks for watching. Bye.